Climate change and food insecurity are closely linked issues that are having profound impacts on human societies and the natural world. Food insecurity is a condition that occurs when people do not have access to enough safe and nutritious food to meet their basic nutritional needs. It is a widespread problem that affects millions of people worldwide, including both developed and developing nations. The effects of climate change are widespread and far-reaching, including rising sea levels and changes in precipitation patterns. These changes have a significant impact on agricultural food production. The community surrounding Booker T. Washington High School has been identified as a food desert. 95% of the students attending Booker T. Washington High School are poverty-stricken. This map is a food access research atlas developed by the USDA and is used to identify low-income areas that are associated with food deserts. The color key represents low-income census tracts where a significant or shared number of residents is more than the set number of miles from the nearest supermarket for both urban and rural communities. Most of the area north and east of 610 is either yellow or green. Booker T. Washington utilizes non-traditional agricultural methods through the use of controlled variables that affect the plant's needs to promote a consistent, optimal environment. Controlled environments are ecological by using less resources and space to produce a larger crop yield. These two systems are being put to use on campus: hydroponics and aeroponics. The aeroponic system sprays a fine mist, water laden with nutrients, onto the root system of the crops. The roots are in an enclosed chamber to keep humidity at maximum levels. Hydroponic systems consist of plastic piping to hold plants in place to deliver a stream of nutrient-enriched water to the root system of the crops. Controlled environments provide 70 to 95% less water than traditional agriculture. Year-round crop production, no weather-related crop failures, reduced transportation mileage, promotes ecosystem restoration, absence of pesticides, herbicides, or fertilizers, no agricultural runoff, more control of food safety and security, and new employment opportunities. Booker T. Washington employs technology in agriculture to increase food production, automate processes, and generate less carbon dioxide gas. Students built a farm bot and programmed a Raspberry Pi to move a robotic arm along the X, Y, and Z axis. The arm attaches different modifications in order to do different tasks, including a watering tool, seed sowing attachment, and soil moisture meter. The farm bot is able to precisely plant seeds for a whole range of veggies, and will individually water each plant, monitor soil conditions, and automatically remove weeds. The machine generates considerably less carbon dioxide and is climate resilient because it uses solar panels to generate power instead of fossil fuels. Typically, hundreds of people are needed to manage crops, but the farm bot allows less human labor and more production. In 2024, NASA will launch the Artemis mission to the moon. Human travels are also being planned for Mars. Trials are being conducted on the ISS to find out which crops grow the best. As NASA is looking to support long-term exploration beyond Earth's orbit in the most efficient manner, there are STEM challenges that are associated with space food production. Growing Beyond Earth is a science fair project involving the participation of multiple classrooms with the purpose of advancing NASA research on growing plants in space. Students at Booker T. Washington are participating in the Growing Beyond 2023 research protocols. Mesomi greens will be grown in a growth chamber similar to the one used on the International Space Station. The chamber creates precise conditions for optimal and healthy plant growth. This experiment will determine if Mesomi greens are a good vegetable candidate for feeding the space crew on long mission expeditions. Furthermore, this experiment shows the possibilities of growing produce efficiently with minimal resources in the heart of communities. This eliminates long-distance transportation, cost, and fuel, while maximizing freshness and nutritional content. Lastly, this experiment participates in looking for solutions in long-term sustainability to feed the growing population. These methods, utilized by Booker T. Washington High School, bring us closer to a cleaner and greener society.